Hey everybody, Mr. Fritz here. We're going to work on this quadratic application problem. So let's take a look at this. This is number 2 from the worksheet that I handed out in class today. And let's see what we have here. We have a suspension bridge and it uses cables for support. A certain support cable hangs from west to east. The support cable hangs in a path that can be modeled by this equation, y equals 2x squared minus 8x plus 26. And it says that y is the height above the surface of the bridge in feet, and x is the distance in tens of feet from the west end. So right away, when I'm looking at this, if this is a model for my cable, I have to think about what kind of a picture this makes. My a value is going to tell me that this is going to be an upward opening parabola. So I'm thinking in my mind something like this. And that's really all I have to go for right now. I guess if this is a cable suspension bridge, I guess it's the kind of bridge that's looking something like this. And we're just getting a small snapshot of this thing. So here's your bridge. And I think this from here to here is kind of what we're after. So first things first, let's sketch a graph of the cable from x equals 0 to 4. And what that tells me right away is, well, a couple things. One is, let's scale my x-axis. If I just care about from 0 to 4, let's just incorporate those values. So I'm going to go every 2 boxes will be 1. So that's 1, 2, 3, and 4. And I'll stick a 0 in here too. And remember, this is tens of feet. So this is, x is the distance in tens of feet. So I'll say distance in tens of feet. Alrighty, and for my y values, I'm going to figure out what kind of scale I want in just a second, but for right now, let's at least write the label for this. So this is height. Let me try writing that again. Height. Well, good enough. All right, so if I want to sketch a graph, I'm going to have to create a table. So off to the side, I'm going to create an XY table. And if I am told that I want to deal with the numbers from 0 to 4, let's just use those tables, or those values rather, in my table. It's kind of nice. It starts off for me by telling me which of the values from the lowest to the highest I want to go. So I'm not spending any time trying to problem solve there. If I plug in 0 for y, I'm going to get all these values to drop out except for the 26. If I plug in 1 for x, I'm going to get, let's go down here, y equals 2 times 1 squared minus 8 times 1 plus 26. And so I'll get y equals, use my exponent first, so this is 2 times 1 minus 8 times 1, which is 8, plus 26. And once I push all these numbers together, I'm going to get y equals 2 minus 8 plus 26, or let's see, that's negative 6 plus 20, so that's going to be a 20. As far as the other values go, same process, plug in the number and use PEMDAS to evaluate. So I'm going to pause it here and fill out the rest of this table. All right, so here are my table of values, and what I'm going to do next is I'm going to plot all these points on my grid. So what I'm going to do is, it looks like my highest point in my y is 26, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 boxes. I think what I'll do is I'll go up by, I think I'll go up by 3s here. So I'm going to scale this, and then we'll come back here. All right, so I went up by 3s up on the y-axis to get my height, and all I'm going to do is I'm going to plot these points. So 0, 26, I'm going to estimate probably somewhere around here. It's my first point. Then 1, 20, probably somewhere around here. It's about a third of the way, or rather 2/3 of the way between the ticks. And I'm just going to fill these out here. All right, so I graphed my my parabola here, connected all my points, and this kind of looks like the section of the bridge that we're after here, so that's good. Let's answer these questions now about this graph. The hard part is over. I want to know, what is the minimum height of the cable above the bridge's surface? Well, if the bridge is down here and the y-axis is the height above the bridge, the minimum height is going to be whatever point is closest to the bridge, which is looking like that's going to be where my vertex is, or my minimum. So what is that height? Well, I know the actual coordinates of that is 2, 18. So my minimum height is 18 feet above the bridge's surface. For letter C here, I want to know how high above the bridge's surface is the cable attached at the west end. So let's think about what we're after here for the west end. In the very beginning of this example, or this problem, it said that the y, which is the y values all on this curve here, is the height above the surface of the bridge in feet, and x is the distance in tens of feet from the west end. So here's my west end, right here. And as I go this direction, I'm going east. So let's see. How high above the bridge's surface is the cable attached at the west end? If this is my west end, how high above the bridge is my cable attached? That is the y value of this point here, which is at 26 feet. All right, and then finally letter D here, assuming the cable runs the length of the bridge, I'm imagining that underneath this cable is my bridge, and we're saying that this is the entire length of the bridge. How long is the bridge? So I'm counting if my bridge is somewhere down here, and it is directly underneath the cables. You can picture here are your pillars that hold up this cable. How long is this bridge? Well, what's the distance from this point to this point? It is 1, 2, 3, 4 times 10 feet. So it is 40 feet. And that's it. And this question is really no more difficult than just graphing a quadratic and answering some questions based upon this stuff. Last thing I'll point out is notice that I did not draw arrowheads at the end of this curve here, because I'm asked to graph this thing just from 0 to 4. If I were to put the arrowheads, that would indicate that this goes on forever. But we're talking about a bridge here, which does not go on forever, and it stops here. So there's your real-world application, and I hope this helps.